Thanks, Tristan. Thanks, Josh. I really like Josh's overview of OpenStack. It was very fair and well balanced, I thought. My goal here, yesterday I gave a brief high-level overview of what OpenStack Swift is and how it works. I will be, on Thursday, talking a little bit more about some of the failure scenarios of that, and it's like, hey, let's see what happens if we delete a hard drive and play with it and do fun stuff like that. But today, I'm going to talk about Swift for new contributors. So the goal here is that all of you, being one of the premier technical conferences in the world, have the capability to commit code into Swift, and so we want that. And so I want to see new contributors coming out of the next 20, 25 minutes. So I will cover in a little bit more detail about some of the nasty hairiness that Josh hinted about how to actually get your patch into an OpenStack project. As a very brief introduction, for those of you who were not around and to elucidate on what Josh just mentioned, OpenStack Swift is a large-scale object storage system built for scale, optimized for durability, availability, and concurrency. It's conceptually similar to Amazon's S3, and it's really cool. I really like it, but I've been working with it for a long time. I used to be at Rackspace. I was part of the team that wrote Swift originally at Rackspace when we had it as an internal project, and was on that team for a few years after it was open sourced as part of OpenStack. This past summer, I'm sorry, I'm in the Southern Hemisphere, in June, so the past winter, whatever you do down here, about 7 or 8 months ago, I left Rackspace and joined a small startup in San Francisco focused on some value-add features around Swift, but this is not a sales pitch. So right now, I am the project technical lead for OpenStack Swift, and that simply means that I do a lot of cat herding and trying to figure out how to get different people who are contributing code to work together and find something to work on. So that is the first question. Where do I find stuff to work on? And I'm specifically talking about developers here, so I can actually say, scratch your itch. The best place that we find new features coming from is when they actually meet production needs. I'm not at all interested, and nobody in our project is at all interested in your really cool idea because you had too much to drink last night and thought it was a really cool thing because you heard that the Facebooks did it or something like that. What I'm really interested in is hearing what your storage pain points are, and let's figure out how to solve them well. And then let's do it in a way that can easily scale up to massive levels. So what is your pain point? Let's figure out that. That is the primary thing. I want production use cases that we do. One of the underlying philosophies of Swift is that it started as a production-ready system. It was open sourced as a production-ready system. If you contribute code into Swift, within a relatively short period of time, your code will be deployed in production at very massive scale all over the world by many companies. That's really kind of cool. So let's say you maybe didn't find something. It's like, it's kind of okay right now, but I think there's some things that maybe, just see what other people have found. I'm kind of new to the project. We use the Launchpad project management site for tracking a lot of things within OpenStack. And Swift has a bug tracking in Launchpad. I probably should do a little bit better of curating some of those bugs, but one of the things that would be very useful, to be honest, is some assistance of confirming some bugs and seeing what's going on there. But there are some things in there that it would be great. Somebody would pick them up and say, hey, let's go fix this edge case or this particular scenario. Also, Josh mentioned blueprints. They're a way to just say, hey, here's an idea I have to work on. Swift has, again, a small set of blueprints that people have said, hey, this is an idea I'm interested in. So once you find something to work on, the next thing you need to figure out is where's the code. So we host the code on GitHub. That's the only thing we use GitHub for. We don't use GitHub issues or pull requests. So you can go there right now, download the code as it exists. It should be, tip of master should be production ready. In fact, actually, I guess an important note is that just last week, on the 24th, We released our most recent version of Swift, 1.7.6, and it's ready to go. So if you are using Swift, upgrade. If you are not using Swift, that's a good version to start with. So once you have the code, something that I found as a developer is I've got to figure out how this new code project works. What does it actually look like? And what is the request flow? How do things work? And here's where we're going to kind of go off the rails and a little free form here. So, actually, I should probably turn on mirroring. Pardon me. There we go. Fantastic. That is low resolution. Wow. Okay. So here we have the Swift code base. And yeah. So I have the current version of the code here. I've opened it up in Sublime Text. And you can see that we have a high-level directory with some subdirectories and some extra files inside of it. Also, oops. Pardon me, just one more thing here to help out everybody. There we go. Okay. So over on the left-hand side, here's their code tree. That's not supposed to keep going away. We've got at the top, within the directory, you've got a few important things. Overall high-level changelog file, the author's file, who's contributed, and basic Python setup things. The entire project is Python. It's a Python WSGI app, so things like that normally apply. At the top level, just going from the top down, we've got the binary directory. This is where all of the basic actual servers live. You can see there's a fair number of them, but they're fairly simple, and there's not much code in here. So let's look at the account auditor. Wow, it's about 6 lines long. This simply is the binary we're going to look at from here if you want to figure out how to, what needs to be run. These are, this is what we go for in the binary directory. We've got a tool called Swift init, which allows you to act as a manager for some of these things. You can say something like Swift init proxy restart, and it will manage the process for you. We generally don't take advantage of things like upstart and initd because we found when we were building it, ops guys really like to have a little more specific control when they were deploying large clusters. Next up is the docs. We've got man pages and also Sphinx documentation, restructured text, fairly easy to edit and look at there. All of these auto-generated docs that are under this source tree right here are hosted at swift.openstack.org, and they are updated with every commit, automatically pushed and regenerated and pushed. The next up is our Etsy folder, and the Etsy folder is a sample config files for every config file that we have. Every option should be in, and I believe is, within these sample config files. These are using standard paste deploy style config files. And so looking at, for example, let's look at the proxy server one. We start with a default section that's going to be there. Every default option within Swift, every default configurable within Swift is commented out with the default that is used as the value. So by default, we're going to bind to every interface on port 80, for example. Looking down, we've got the pipeline, which is, if you are familiar with the way that WSGI applications work, you have a series of middleware plugins that take the request on the way in and pass it down to the next one in the chain, and then pass the response all the way back up the chain. So the pipeline here, you can see this is what we're doing. Notice it's not commented out. This means it is a required option that you are forced to define. And then the various sections here. So we've got the proxy server in the pipeline, which means that we also have a proxy server section. and the following sections, for example, a couple of sample sections for authentication. Let's see, we've got the health check middleware, some memcache layers. Anyway, it goes on down. We've got lots of options in here, lots of different knobs you can tune. Next up is, let's skip down to test because it's fairly simple. In here are automated unit and functional tests. These are generally not, you don't generally mess with running things out of this directory. We've got some helper scripts for both unit tests and functional tests, and something called probe tests, which are kind of in between unit test and functional test in the way you can test the insides of a black box of a distributed cluster. The big part where the code actually is in the Swift directory. And the Swift directory is then organized into the 4 basic pieces of Swift that I talked about yesterday: the proxy, the account, the container, and the object, and then a common directory where there are utility methods and things that how to deal with process management things, how to deal with standard HTTP things. So first off, looking at the common, again you can see we've got a nice utility. We've got utilities file, for example, things dealing with WSGI applications, exception handlings, constraints within the cluster. How those are set and defined. And then we've got 2 directories. The ring is where the ring data structure is stored and managed. This is the data structure that actually determines where data is placed within the cluster. If you want to figure out how data is placed in the cluster, or change that, add new features to it, this is the place to look. And then we've got the middleware area, and this is the middleware that ships with Swift. Some interesting features you can optionally add on. Some things are fairly common, fairly basic that you should have all the time, like some caching layers, and this is just a nice way to, a nice caching layer that's going to work in an evented, highly concurrent system. Again, so a sample auth file, an auth middleware that plugs in with a keystone from the rest of the OpenStack project. ACL handling. This one, actually, I'll talk just a little bit about this one because it was just committed mere days ago. This bulk middleware allows you to do bulk operations. For example, say, I need to delete 1,000 objects with one command. Or, for example, the one that I'm really excited about here is let's upload a tar file and explode it on the back end. So I want to upload a tar file, and then each file that's actually referenced inside of that tar file is now an individually addressable object within the cluster. That's kind of a cool thing, I think. So now the proxy server. The proxy server has a server. Naturally, this is the actual process that runs and accepts and responds to requests. It handles, based on your request, it calls a particular controller, so the object controller, container controller, account controller, and then, of course, a common high-level class there. And the proxy server will then communicate with the back-end object server, container server, or account server as necessary. Each one of these directories are very similar. They have a server, and then they also have the background consistency processes, the code for that. The replication and the count and the auditing is common across these. The object, there's also the updaters and the account reaper. We don't need to go into detail on those. Now let's trace just very high level, very quickly, the overview of the data flow within a request. In the, let's get a little bit more room on the screen. Nope, not that one. Where's the sidebar? Right sidebar. Perfect. Or, better yet, there we go, full screen. Great. So now we are in the proxy server, and this is the entry point for everything, a standard WSGI app. So we can look all the way down at the bottom and see that we have, where is this actually? Let's see, proxy server pi. Okay. Yep, that's where we are. Yes, down at the bottom we have our factory, which calls our application class. And inside the class is instantiated, configs are set up, and then when a request comes in, we go to the call method. It's a standard Python callable, and this is what actually handles everything. The first thing it's going to do is going to set up the appropriate caching as necessary and call handle request. Handle request will get the appropriate controller. There's handle request. It gets the appropriate controller as necessary, and then will, where is that next one? It will call the handler on it. And the handler is the actual request method that is used here. So we're looking at the request method. So this is like a get, put, post, delete, things like that. And then we will look for a controller, say the object controller. Let's say we're going to do an object put. So in this case, we have a method on the object controller that says, here's the put. So the handle request will call here, which will then, of course, do things like check the container info and make sure things actually work. In this case, this one's probably one of the more complicated pieces. Probably shouldn't have used that as an example. But eventually, we're going to go down and we're going to get the appropriate storage nodes to talk to in the background, set up some concurrency here, and then start get connections to the backend objects, start serializing all of the data sent to the backend server, and then we will make sure everything has been read correctly, and if everything is fine, well, actually, to check if everything is fine, we check to see what the status codes were responded, and then we will choose the appropriate response to send back. In this case, for example, if you're doing a put on an object, Swift requires that you have a quorum of the replicas have responded with a success. So if you have 3 replicas, 2 of them must respond with a success before the client will get success. This is really what the proxy server does, is coordinates the communication with the backend servers. On the backend servers themselves, if you're looking at the object server itself, it again is also a WSGI app. And so down here at the bottom, you've got an app factory which instantiates an object controller, and that will set up the appropriate config options and has its, what are we doing here? Its call method, I don't know what's going on here. There we go. Calls the call method, and it's going to write the actual data to disk, and then sends that back up through its own appropriate middleware, and send the response back to the proxy server, which will then coordinate the responses, send it back. So high level here, the starting point for everything is the proxy server. It's a standard WSGI app. You look at the call method on when, and that is how the request actually gets in. At that point, it's passed to the appropriate backend server. It goes through the exact same thing because that is simply another WSGI app on the back end. Then that's going to be thrown back up the pipeline, back over the open connection to the proxy server. The decision will be made from all of the back-end storage servers and then sent to the client. So, that being said, let's say, quick pop quiz here. There's a method within Swift that is called split path. It's very useful because it will take the path info off of the URI and figure out, is this actually an account request, a container request, an object request, or is it invalid overall? So this is something that would be nice and common to all levels of the stack. So where would it live within the Swift code base? In common, that is correct. 3 points for you. Yay, Swift common, utils, and you can see that we have split path right there, nice doc strings, and there you go. Ta-da. So now, switching back. So now you understand how this all works. You've made your magical patches, and everything is good. So here's the hairy ball of nastiness. We have the CLA process, and that offers a couple of, a couple being 4 or 5 extra steps, including human intervention, to get your code in there. So high level, we use Gerrit to do code reviews, and we have the CI system run by Monty and his team to do gating on all of the patches. But to even get it into Gerrit, you first need to sign the CLA. There is a fairly verbose document on the OpenStack wiki on how to contribute, named as such. So the basic process is you need to sign, do a DocuSign of the OpenStack CLA. And then you need to add your receipt number to the appropriate wiki page on the OpenStack wiki. At that point, you need to petition for membership in the OpenStack CLA Launchpad group. And then somebody who is a member will be able to approve you after they have verified that, that the signature you put on the wiki page is appropriate. At that point, you can now download and configure the Git review tool, which has some very nice helpful methods for submitting into OpenStack, although it technically is not exclusive to that. And then you can Git review your patch, your branch, and it will be submitted into the appropriate place, and everyone else can look at it. Yeah? Fantastic. The CLA process is going to get a lot simpler in about a month, because this is the thing that I hate about the whole process, because it's... We finally got the lawyers to agree to just let us do something really simple. Good. Have Aaron accept your CLA right. Fantastic. Okay. So this is going to get better, and so do it now. It's a one-time cost, but it will get better for new contributors later. So once you've done that, once you have submitted your patch, at that point, each group, each open source project within the group is essentially organized into contributors and core developers. The core developers, in the old school terminology, are the ones with commit access, essentially. Not directly, because it is a gated project, but the point is they're the ones who can actually trigger the gates to merge it into the trunk. As a general rule, all of the OpenStack projects require that 2 core contributors have signed off on your patch. I found, I've only really worked with the Swift project in this sense, but I found that all of the core contributors are extremely, well, most of them are extremely smart, and I'll accept myself on that. And very willing to help people out and say, yes, that's a great idea. However, when you're doing it over here in this use case that we have, it's not going to work. Or, hey, did you consider this maybe alternative approach? Very good, welcoming community in that sense. Very patient with working with people to get your patches in. At that point, it's approved for merge. It's merged in after it goes through the gating process. And congratulations, you're now an OpenStack contributor. So now you need some help. This is my last slide. So if you need some help, the absolute best place for real-time feedback on what to do is on IRC. We've got a couple of channels that are the canonical channels for what to do. OpenStack is a great place for people who have questions about the overall project. OpenStack Dev is historically the place where if you are a contributor and want to ask questions about that, it's a good place to go. A lot of times, as OpenStack has grown, it's gotten a little hard to separate the signal from noise in OpenStack Dev. And so many of the projects, including Swift, have set up an OpenStack dash, their project name. If you have questions about contributing into Swift, I would encourage you to ask in OpenStack-Swift. I didn't put that up here because I'm not trying to promote it as, hey, if you've got Swift questions, join that. If you've got Swift questions, come in OpenStack. I'll be happy to help you. You can also go into the OpenStack mailing list, list.openstack.org. Can sign up for that. docs.openstack.org, swift.openstack.org have some very good docs, high level. And then there's a lot of community on-the-side documentation. The company I work for, SwiftStack, provides a lot of helpful docs and videos about different parts of Swift and how they work. Just some community blogs that I've seen. Julian Danju has written a couple of good blog posts. Shmuel is one of our core contributors and has written quite a few good blog posts and tools around how to use Swift. And that's it. So we are right now, as of today, have 94 contributors into Swift. So I certainly hope that somebody in this room will become our 100th contributor into Swift, and soon. So, is there a what? A free download of Swift. No. If you become the 100th contributor this week, I will buy you a beer. Otherwise, you have to come to San Francisco, and I'll buy you a beer there. So, what's that? There you go.
Actually, are you going to emphasize the value of being an ATC? So
That is a good point.
Nobody talks about this, but the number one reason you want to be a contributor, aside from the fact that it makes you attractive to members of the OpenStack, is that active technical contributors go to the OpenStack Summit for free. So just think of this as 5 days of having people buy you alcohol continuously. So much alcohol. Ridiculous amount of stuff. So much alcohol.
So yes, you get to go to the OpenStack Summit for free, which is a fantastic conference about getting people together on building these really cool stuff. And also it gives you voting privileges within the OpenStack organization. And so if you want to be PTL for Swift instead of me, you can run and garner your votes, and I may vote for you. So
You can vote for anybody except for yourself.
it's really a great thing. So you know, kind of the high level overall, you know, I can say personally, there's been nothing better in my career than OpenStack. And it is something that I truly believe is going to change the world. I'm going to talk a little bit more about my high-level philosophy and why I think OpenStack is awesome on Thursday. So thank you very much. Questions? Yes?
What's the minimum system you need to get an OpenStack, as you mentioned, up and running?
That is a great question and something I should have addressed. All of the developers for OpenStack run a Swift all-in-one environment. I have that running on a 1 gig cloud server. I also have a VM running in VirtualBox on this laptop. It's kind of a powerful laptop, but I've run it in a VM on a MacBook Air before. You don't need a lot of hardware to get the conceptual pieces running together to be able to do functional testing. You're going to need a lot of hardware to actually test at scale, but that's why we have a big community. So you can run that. We've got some documentation on that. Swift.openstack.org has the instructions on how to get up and running. I was just going through that this last week, preparing for this week, and I realized it's a little out of date, so I'd be happy to talk to you about that. But yeah, not much at all.